Welcome to Competency 17 Practice Test Questions. This is 5 out of 5. Number 17. A state official claims that the mean age of all freshmen in Philadelphia schools is 14.6 years. A current study of 45 freshmen at several Philadelphia schools reveals that the mean age is 14.9 years, with a standard deviation of 1.2 years. At the 5% level of significance, what decision should be made? Okay, first we need to decide. Okay, we do have level of significance. Okay, so that is going to be a z-test. Remember, we have a z-test and a t-test. How do we know we want a z-test? Because 45 freshmen is greater than 30. Okay, who's making the claim? The claim was already there. And what we're seeing is we have a new study. And with this new study, we don't have any other information. So what you really have to say, okay, is this new study different enough that we need to consider it, that we need to reject it or keep it? Okay, accept it, what it is, and go recrunch our numbers. Okay, this is going to be, all right, remember our tests are in our stats, you arrow over, and remember we have a large enough population that we're going to use number one, RZ, and we're using stats, not data, so we keep stats. Okay, we're going to go with, remember, mu naught is the original. So that's 14.6 is our mean age, which is continuous. And deviation, oh, there it is. Okay, from here on out, remember, the other information down is from your sample. Okay, so their standard deviation is 1.2. And let's enter the sample mean, remember that's what X bar is 14.9. Okay, now we enter. And how many do we have? We have 45 in our test. Okay, enter. This is where we've got to make a decision for sure. There is no claim saying, okay, it's got to be larger, it's got to be smaller. We just need to see if it's significantly different enough. Okay, I'm going to select that it is significantly different enough, okay, that or the person that's doing this needs to consider keeping it or rejecting it. Okay, first we need to find the p-value. All right, so let's push enter. All right, remember, you got to arrow down on some of these. Okay, our p-value is going to be that 0.9, so we can get rid of C and D. Now, remember, how do we know to accept or reject? Remember, rejecting is when our p-value is less. We keep what we've got, the information, so we're going to keep the 14.6, okay? If, let's see, RP equals 0.09, well, actually, that is greater. No. Yeah. That's greater than 0.05. So we need to accept claim cannot be rejected. Okay, that's what we need to say. Cannot be rejected is the same as accepting their claim. We're going to accept their claim, and then our numbers have to be completely reworked. That's really what they're saying if you're keeping data. All right, let's go with number 18. Okay, a report in a noted journal claims the people that people sneeze 20 times per day. That's our average. Assume that the number of times people sneeze per day is a normal distribution that is allowing us to use these t-tests, z-tests, whatever. A well-known doctor conducts his own study using a sample of 13 patients. It says he and she. We'll just put a her. Okay. She finds that the sample mean, that's what X bar is 18. And then that the sample deviation, that's why they have just a plain X there. S. That's a sample deviation at a 1% interval of significance, a level of significance. Sorry. Okay. So because we have 20, no, not the 20, I'm sorry, the 13. 20 is where we started. Our mean we start with. 13 tells us that we have to do a t-test. That over, go down to the 2. We could have arrowed down, but whatever. Okay, now our original claim is 20 times a day. The new claim says, okay, make sure that's where the mean goes. Yeah, 18. Okay, now the sample standard deviation. And notice it says SX. That means sample deviation. Now that's a little confusing, but that's what that means. It means put in your sample information. Enter how many patients. We have 13. Now, we need to make a decision. And it is different from above, and it's very confusing. But I tested both, and if you just put the not equal to our original, meaning that it's not equal enough that we can change, you will not get the numbers they give. Well, let's think this out. Who's making the claim? The original has the claim. Okay. All right. Let's look at number 1, the difference of these, so we kind of make sure we're doing it correctly. Okay. Well, we have a claim of a medium age, and this one has a claim in a current study. The difference here, I think, mostly with this, you kind of got to crunch your numbers to make sure you're right. But regardless, what we're really looking at is we have a well-known doctor making a new claim, and this well-known doctor says, okay, that's just a journal. Is that a valid claim? This doctor is saying, no, that isn't a valid claim. In your journal, this is going to be less. It is actually less. So what we want to do is say that our claim is less than, move over, we're saying our claim is less than the original that was out there, okay? I know that's very confusing, but usually in these tests that the answer choices and you have better wording than this sample question, that you can think through it, be logical, and you're going to come up with a correct answer. Okay, all right, let's see here. Yes. Okay, we've got a good p-value rounded, so that gets rid of C and D. Our p-value rounded is a 0.007. Now, are we going to reject or accept? Our p-value of 0.007 is definitely less than 0.01. Remember, that tells us, okay, hang on. Okay, yeah, I'm sorry. That tells us that we must reject their claim. We keep our claim. We keep our claim, or the original claim that we began with. So that is A, that the p-value, the claim must be rejected. So whatever research this doctor is doing, it isn't significant enough. Maybe they got to go back and try it. Number 19, consider the following table of X and Y values. What is the value of correlation of the correlation coefficient? Okay, that is the R in your calculator, not the, oh, if I could write, if everything would be wonderful. Seriously. Okay. All right, now that would be the R, not the R squared. That's a different, that's a determination, okay? It's different, it's got a couple different names, but it has a totally different meaning and a different purpose, okay? All right, so what do we need to do? Okay, the first thing is we need an L1 and an L2. Okay, so stat, enter. Let's go edit. Okay, and we're seeing that we need 3. I'm just going to enter these in. There's not enough to clear out, do all that stuff. And then I can just clear that. Oh no. Remember, you can't just clear, you got to enter. Let me delete. Okay, all right now. Oh no, what was I doing? I totally forgot 9 or I didn't type it right. Okay, there we go. Definitely not a perfect person. Okay, there we go. This is why you look and double check and you look over at your data that they gave you and you keep entering. So we got 10, 13, 15, we need 20. Okay, double check. We're going to use L1, L2 now. And I'm noticing something on the next one. And on a test, they would say, use this data for both these questions, and then you could look at both at the same time. They're saying that you need a line of best fit. And that tells me something. Let's go through the motions, and I'll tell you as we go. Okay, you have to back out of this. Then we do stat. We're going to go over to calculate, but we need number 4. We're doing a linear regression in that particular one. You can measure those. There's another one in there, very similar, but anyway, we need to put it in second L1, remember? And then I need L2, and then we do not want anything in the frequency list. Now, we need to go down. See where it says store regression EQ? That means equation. And we need that equation to be in our y equals because that's how we're going to get the table to get these answers down here. That's how you get your best fit. You get to look at it and graph it. Okay. Now, that means that we need to do vars. Go over and see where it says function. That means I'm going to take a function and I'm going to put that in Y1. That's what I'm telling it to do. Enter, enter. Okay, first let's get our R. That's 0.98 rounded. Okay, that's A. Fabulous. Okay, now let's go to our Y. Okay, first off, we don't want anything in Y2, just in Y1. And you need to turn off, arrow up and over, and push enter to unclick that. Okay, that is our equation. Now, let's go to graph that. Okay, and I'm doing this for a reason. Okay, notice what happens. Okay, so what that's telling me is I need to change my zoom and I need to either go to the square or the standard. So I'm going to do 6. See, it automatically, okay, and I need to change some things. Remember, we played with our calculators, so you may not like this. So we can format second format, and I like my background, but I want my axis to be, or to make it all look decent, I could just go down and put that on a black background. If you haven't joined me for my other videos prior to this, during this competency, and you want to see some of this, okay, okay, there it is. It's like, when am I ever going to get there? Okay, all right. There's no entering or anything. I just second mode out. Okay, now. You want to see how to do all this and play with it? See, it came up. my blue line doesn't show up well. So I'm going to go over, and enter. I'm going to change that navy to something a little, how about the light blue? Works for me. I have to go down to OK and enter. Now let's graph. Okay, there we go. Ooh, looks pretty decent. Okay, if you want to know how to change all these colors, go to my prior videos just before this. I think it may have been the last one in the Competency 17 practice part, not in the test part. Go look. I give you some clues on how to do all this. Okay, we got a nice line, but that's not what it asks us. It asks us which one of these points lie on it. Hey, not a problem. We want to go table. Second, graph. There's our table. Let's do a little, we got 3. We need to check 3, 5, 7, and 9. Okay, 3, no. 5, no. 7, no. 9 says 13 point. Perfect. I gotta move up a little. And that's it. Okay, that is actually our final question in our practice test questions. Please, if you like this video, could you please give it a thumbs up? And if you like the things that I'm doing so far, could you please subscribe to our channel? Thank you so much.